Elusive blaze star nova could finally appear in our skies this week after multiple false alarms. Sky gazers have been waiting for over a year to see a recurrent nova that creates a temporary super bright star every 80 years or so. A new study suggests that it could finally happen this week, but nothing is certain. A bright new star could emerge in the night sky later this week if a distant star system erupts as expected, data suggests. However, scientists have been predicting the imminent arrival of this spectacle since early last year, suggesting this long-awaited phenomenon is much harder to predict than previously realized. T. Corona Borealis is a recurrent nova that repeatedly explodes, creating frequent and somewhat predictable pulses of light that linger in our skies for up to a week. And these flashes come from a binary star system made up of a hefty red giant circling a super dense white dwarf that's around the same size as Earth. The smaller star is slowly stripping hydrogen gas from its partner and will eventually devour it over millions of years. However, as material falls into the white dwarf, some of it accumulates on its surface until the pressure gets so great that it ignites in a powerful, super bright blast. This type of cyclical blast is called a nova, not to be confused with a supernova, in which a large star explodes completely, leaving only a shriveled core behind. TCRB, also known as the Blaze Star, last appeared in our skies in 1946, but has been recorded at multiple points throughout history, potentially dating back as far as 1217 AD. And by looking at the past outbursts, scientists have determined that the nova explodes roughly every 80 years, meaning that it's due to appear anytime now. However, we have already had multiple false alarms predicting exactly when it will appear. Hopes of the nova's imminent appearance were first raised in late 2023, when the TCRB system dimmed, just like it did before the 1946 appearance. But the hype around the once-in-a-lifetime spectacle really took off in 2024, first in March and then again in August, as different researchers claimed it was close to happening. And ever since, stargazers have been waiting for the blaze star to appear, but it has remained elusive. But another study published October last year in the journal Research Notes of the American Astronomical Society, a lone researcher proposed a different set of likely dates for the celestial spectacle after analyzing the finer details of its previous iterations. The first potential window for the blaze star's appearance is marked as beginning on Thursday, March 27. The study's author, Jean Schneider, an astronomer at the Paris Observatory in France, wrote in a paper, "But if we do not see the nova within around a week of this date, we will have to wait for more than 7 months for a stellar explosion to appear," he claimed. In reality, the TCRB system has already exploded again, and we are just waiting for the light of the next blast to reach us as it travels 3,000 light years across space between it and us. And when will the nova appear? The blaze star is hard to pin down because the amount of time between each of its recorded appearances can be either increased or decreased by around 1.4 years on average, and there is no pattern suggesting which way it will swing, and as a result, researchers have had to rely on monitoring the TCRB system for changes in brightness to predict its next appearance. However, in the newest study, Schneider reanalyzed the time differences between eruptions and found that each gap is almost perfectly divisible by the orbital period between the red giant and white dwarf stars, which circle one another every 228 days. Following this rule, the next nova should appear around March 27, but if it does not show, the next dates for this potential arrival are 228 days later, on November 10, following by June 25, 2026, and February 8, 2027. Bizarrely, there is no clear reason why any known recurrent nova would follow this pattern. These predictions, quote unquote, are only empirical extrapolations, Schneider wrote. There is, at this point, no physical explanation behind them. But Schneider postulates that if there were a hidden third star in the TCRB system, then there would be a specific point on each orbit where a third star is also closest to the white dwarf. At this point, there could be an extra helping of material being dumped on the superdense star, which may be what triggers the explosion. However, this is unproven. How to see the blaze star? Predicting exactly when the nova will reappear is tricky, but what researchers do know for certain is where the blaze star will appear on the light from TCRB finally once the light reaches us, because its position in our sky is fixed. The temporary star will shine in the Corona Borealis constellation, which translates to Northern Crown in Latin. And this constellation is not very large, but it is sandwiched between the larger Hercules and Bootes constellations, which are much easier to find and contain specific stars that can be used as guidelines to find the nova when it appears, according to Life Science sister site space.com. The exact locations of these constellations in the night sky depend on where you are on Earth and the time of year when the nova emerges, but they can be easily found using websites such as theskylive.com. The star will have an apparent magnitude of +2, which is roughly equal to the brightness of the North Star. As a result, it will be one of the brightest objects in the night sky, visible to the naked eye. However, if you have a backyard telescope or a stargazing binocular, you'll be able to see it for several more days after it disappears from everyone else's view. This is by Harry Baker on Life Science. Please leave your comments, and thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.